Now let's try to understand what is there inside the JVM. So what I will do is I will just go back here and let me draw a bigger JVM because that's what we are focusing now. If we talk about the outer box for this, that's your JRE, outer box for that is your JDK, but let's focus on JVM here. And I also name it JVM. Now what we normally do here is, this is where you execute the code, right? Now question arises, how exactly we are going to execute the code? Of course, there is something called a runtime or the runner which will do that. Here we'll focus more on the memory level. What happens when you create a variable, when you store a variable. In your memory or inside JVM memory, we can categorize into two parts. The first one is this. This is how it looks like. Of course, I want you to guess. So basically this is a area where you can store your data, and that has a feature which is last in, first out. Example, let's say if you send data, which is 5, 6. So let's say if you send data 5, 6, 7. Now the first value which entered was 5, second value is 6, third value is 7. Now when you try to get the value, you will get 7 first because that is last in, first out. Now this is called stack. So basically you have a memory which is called stack memory. Now apart from this memory, you have one more which is you call as heap. Now on purpose, I'm drawing this type of image where it represents that it expands, right? So this memory here is your heap. So basically we have a stack and we have a heap memory. So in the stack, you store data in a different sequence, and in heap, you have an open space. Now, before we jump into this memory, how it works, let's focus more on this code, okay? Remember when we talked about calculator and then we have talked about these two variables? Now here, when you talk about this n1 and n2 variable, they are variable, but they are local variables, okay? Just to reiterate, those are called local variables. Now, what do you mean by local and what are different type of variables we have? So if I create a variable here, let's say num. Now in a calculator, we have a num variable, and then in a method like add, we have n1 and n2. That's right, the n1 and n2 are part of add method. Now here, the n1 and n2 become your local variable, and num here becomes your instance variable. That's right, the word is instance. Now what happens is, the moment you create this, the moment you have main, now the beauty is every method will have its own stack. That's right. It's not just one stack. Every method will have its own stack. And if you can see in this code, we have two methods, right? So of course you will be having two stack. What I will do is I will just redraw the stack to accommodate more data. So what I will do is I will just zoom it a bit. So let's say we have a stack here. Okay, this is your first stack, and a stack will have two sections. Okay, and basically it will have two columns and multiple rows, depending upon how much data you want to introduce. Now, if we talk about this main, this particular stack is actually your main stack. So I can say this is my main stack. Now in this stack, you will be having your data. So what data I'm talking about? If you go to the main method, if you can see, we have a variable A. Okay, now that's also a local variable. Okay, so I can say, hey, I have a variable which is called A here. So I'm just writing A there. Now what's the value? At this point, there's no value for A. So I will just ignore that part. Maybe let's not even mention that. Once we talk about string, then it will make much more sense. Let's start with the variable here. Maybe I can create some more variable just to understand. So I will say int data is equal to 10. So what I'm doing is I'm creating a variable, which is a local variable again, inside the main method. And you can see, we can say this is my data variable, and the value for that is 10. Straightforward, we can assign the value 10 because that's a value. So basically your stack will have a key and a value. A key would be name of a variable and value will be 10, the value itself. Now coming back to R1 here. Okay, let's ignore this obj as of now. And mind you, this obj is also a variable. So it will be a part of the stack. So data, obj, R1, they all are variable. So it says, okay, I want to have R1 as well. So I got R1 variable, but what is a value for R1? And that's where it will basically call the add method. Okay, so it will call the add method, but we don't have an add method in the memory as of now, right? So if you see in this memory, nowhere we have add. So basically what we have to do is it will create a new stack out of it. So we got another stack, and the name for this stack would be add. And of course it will have two sections and multiple rows. So two column, multiple rows. Now if you see in this particular add, we have two variables, n1 and n2. So of course we have to define those two variables, n1 and n2. What are the values for these two variables? We are passing them, right? 3 and 4. The moment you pass these two values, it will go to n1 and n2. It will assign those values. So the value for n1 is 3. The value for n2 is 4. Okay, that's good. And then you are executing add method. So in add method, what we are doing is we are just adding those two values, 3 and 4, which is 7. It will return the value. Whatever value you have returned, it will return the value with this particular method to R1. So that's right, we got R1 as 7. I hope this makes sense. Cool. So we have done the changes there as well. So R1 is now 7. What else? Now what happens to this method add? We have called it, right? So there is a special method area where you have a different stack of calling methods. So when main call add will execute first. Once add is over, it will be gone. At this point, let's not talk about the function calling. Let's only focus on the data areas. So basically this is what we do there, right? But what happens with the object here? Now that's tricky. And what happens to this num variable? Where do we put the num variable? In the add stack? In the main stack? No. If you can see, num is not a part of add, is not a part of main. The beauty is you can actually print the value of, or you can use the value of, you can use a variable num inside a method. I can actually print the value of num here. So maybe I can set the value as, let's say 5, and I can actually use this num inside a method. See, using a particular variable and declaring the variable inside a method are two different things. At this point, we are using it. We are not declaring it inside a method. N1 and N2, they are declared inside the add method, but not num. And that's why if I can show you, if I compile and run, it still works. You can see we got num, which is 5. So we can use it. But the question is where it resides. Not does it resides in add stack or main stack? The answer is, and that's where we have a heap memory there, right? Now inside the heap memory, what happens is, just focus on the line number 20 here. On line number 20, what we're doing is we are saying calculator obj. Now, if you remember, we have talked about this multiple times. This obj is not an object. Now people coming from C++, you might be having this urge of calling obj as object, but no, that's a reference variable, but that's a variable, right? Now this variable, where it will get created, it was declared inside main. So of course we have to say obj here, but the question is, what will be the value? Now for that, you have to understand what is happening here. Now when you say new calculator, it will simply create a new object. Where? It will create the object inside the heap memory. This is where you will get your object. And inside this object, you will be having two things actually. So let me just draw the first object quite bigger, and later on we can draw it small. So this is your first object. The object will have two sections. The first section will have all the variables, all the instance variable, not local variable. You know why? Because local variable are part of a stack. So they're part of the stack, not of heap. But if we talk about the instance variable, like we have num here, they are part of the heap memory. And this is where you can say variable name, num, the value for that is, let's say 5. We have assigned 5, right? And then this particular object will also have methods, and in this heap, we are saying this is an object of calculator. It will also have the method declaration, so it will have add method. But then it is only have the definition of it. The actual area which add will consume will be of stack, okay? If that makes sense. Of course, we can have extra methods as well. At this point, we only have one. Now this particular object will also have its own address. Let's say the address is 101. Of course, right? When you store the data, it has to get some address. Now that's 101. Of course, it will be a complex address. At this point, I just want to keep it simple, 101. Now this 101 will be stored in the stack. So every time when you say obj.add, the actual execution starts from stack itself. You say, okay, someone is trying to call. Example, if we talk about line number 21 here, we are saying obj.add. That means we are using obj object to call the add method, but it belongs to obj object, right? Which is the object here. So it will simply use this particular address. It will jump to the object and it will call the add method. So can we say there is a link between stack and heap? Yes, because of the address, right? And that's why you can use this object multiple times. And that's important. In future, we are going to talk about anonymous object as well, and we'll discuss why this link is important, and it will make much more sense. At this point, just imagine there's a link. Every time you say obj.add, you are going from main, looking at the stack, then you are jumping towards the heap to look for the object. I hope that makes sense. The good thing is we can actually create multiple objects. I can just copy this line, or maybe I can say code reuse, and I can create another reference, which is obj1, and we got a new object here. That's right. In total, we got 2 calculator objects. So with this changes, what we are getting is we will be getting a new object here. Let's say the address is 105, and it will have the method. It will also have num variable, and the value will be 5. Of course, you can change it, and you can have add method. Okay, this is num. Okay, not n, but imagine that's num, and you'll be having obj1 here because in main we have one more declaration of obj1. It will have the address 105, and you can imagine there's a link between stack and heap. Okay. Now, when I say these 2 different objects have 2 different value or 2 different num variable, but they have the same values of now, right? Example, if I come back here, you know what I will do? Just to simplify this thing more, I will just comment all the other print statements to see only one output. So here what I'm going to do is I want to print obj dot. That's right. If you want to even use the variable, the instance variable, you have to use the object name, which is obj1. In fact, the first object is obj. The second object is obj1.num. So you can see we got 2 objects, and we are printing the value of it, each num value. And if I run this code, you can see we got 5 and 5. You know why? Because that's the value you have assigned. Now my question to you is, before printing the value now, if I say obj.num is equal to 8, you can see I'm changing the value of only one object. What do you think? Will it reflect on both the object or only one object? Let's try. So when I say compile and run, you can see it is impacting only one object. It's because there are 2 different objects, right? Example, let's say if I have this phone, this is Samsung, and let's say I have the exact other Samsung phone, and one of it, so let's say if the glass of one phone is broken, will it affect the other phone? Of course not. They are individual phones, and damaging one phone will not affect the other phone. So that's the important point to remember here. So yeah, that's it about the data area. So we have different areas. We have stack and heap. Of course, we'll talk more about this in the upcoming videos, but that's how it looks like.